Hello everyone, welcome to my new science school chemistry class. In this class we are going to discuss electronic configuration of an atom. Electronic configuration simply means the arrangement of electron in an atom. When we say electronic, we always refer to electron. So how electrons are arranged in an atom, but this will be general overview. In our subsequent classes, we are going to discuss electronic configuration in details. So by electronic configuration, we mean, as I said earlier, we mean the arrangement of atom around arrangement of electrons around the nucleus of an atom. So if we take example hydrogen, as I said earlier in our previous lessons, I said that hydrogen is just nucleus and one shell, and I said this shell can only carry 2 electrons. In case of hydrogen, we have single electron, so we have single electron here. Now this is electronic configuration of hydrogen. Electronic configuration of helium is almost the same thing, but instead of single electron, we have 2 electrons, and within the nucleus we have proton. For helium, we have 2 proton and 2 neutron. So electronic configuration is aimed at describing the arrangement of an atom around the nucleus. This is hydrogen, H, and this is helium. These are very important. This arrangement is very important for an atom stability. For example, those electrons that are within the shell of an atom determine how stable is that atom. For example, this hydrogen, in general, there is one general rule: a shell always tends to complete its electron. So if a shell requires 2 electrons to become full, so it always try to make that, or try to achieve that fullness stage by acquiring electron from other atoms or from anywhere. Instead of the shell to stay with only single electron, it tends to give or accept 1 electron, so that it becomes either full or no shell at all. Why? Because they always tends to be full or no. That's why we categorize shell, or we categorize atom based on their outermost shell tendency of being full or losing the electrons. If we have a shell that is 2, as we gave for helium, if we have shell that can carry 2 electrons in case of shells of helium or hydrogen, if it is only 1 electron that is in the outermost shell, this shell will have equal tendency of gaining electrons from somewhere to put in this let me change the color here, to put electron on this shell, so that it will become double electron, that is 2 electron on the same on this shell. This will make it to become, this fullness is termed doublet. Okay, I think it's B here. Doublet stage. When it's doublet, that means it is full. The shell or the innermost shell or this first shell is full now because it is having 2 electrons. This is for this state of helium, because if we see helium, if you look at this helium atomic configuration or electronic configuration, is having 2 electrons at the outermost shell. This stage of this electron atom is suitable form. It is what? Suitable. Why? Because it has completed the requirement of the outermost or of the shell. That is, the shell is housing 2 electrons. In general, for reaction to occur, there should be activity in terms of sharing or transfer of electron. Either to transfer electron from one atom to another or to gain electron. For example, this hydrogen can gain electron to assume this helium state of stability or this helium doublet state. That is why for reaction to, that is why this kind or these types of atom or this form of completeness of outermost shell would render the element or the atom as inert, that is not reactive. It will not react with any other other atom, but this one that requires 1 electron or single electron will tend to be reactive, because that gaining of electron will cause the reaction. Imagine you have 1 electron from other atom or from another atom somewhere and give 1 electron to hydrogen. That means this transfer of electron between hydrogen and that atom will cause reaction between the 2 atoms, that is hydrogen and that atom. Let's say we have sodium here. Sodium normally in the outermost shell is only single electron, and that single electron will be transferred to hydrogen. That will cause reaction. Why? Because that transfer or that activity of electron sharing or transfer from one atom to another is what is the it is what forms the basis of chemical reaction. So this electronic configuration of hydrogen and electronic configuration of lithium. Now, since we said this first electron always house 2 electrons, it houses only 2 electrons. Then the next atom which has lithium, okay, lithium has this nucleus. Let me say this is nucleus, and it has first shell, and let's say we have 2 electrons for the first shell, and lithium has 3 electrons. For you to put other electron, you must draw another shell. This shell, then yes, this shell will house the next electron. Then you put the next electron here. That forms the electronic configuration of lithium. So if I see this anywhere, I would say, oh, this is lithium. Why is that lithium? Because I have 2 shells. I have 2 shells with 3 electrons. The innermost, which is this one. When I say innermost, I mean in, that is inside. Then innermost, the most inside. So the shell that is the most inner, that's what they call it, innermost. So when I say innermost means the one at the extreme, oh, how do I put it, the one inside, the one which is inside than any other. That's the innermost. So now innermost shell houses 2 electrons. Then this one that is outside since there is no another shell outside, this, if this is innermost, that because it's inside, then this one is out, then it will become, or it is term, or the term for describing the the shell that is outside is called, or that is more outside is called outermost. So when I say outermost, I mean the one that is far outside, or the one that is outside the most. So innermost shell houses 2 electrons always. Then the second shell now houses, or can house 8 electrons. But in case of lithium here, we only have 2 electrons for the lithium. So we just, in the outermost shell, we just put single electron. As I said earlier, any shell will always tend to fill the shell, or make the outermost shells as full as possible. They will make sure that any atom will make sure that the outermost shell is full, so that it will be stable. If it is not full, that means this electron, or this atom, will have the tendency of reacting with another atoms to see that the outermost shell is full. In case of this lithium, we have outermost shell, which is here. We have only single electron on the outermost shell, or in the outermost shell. What this lithium will do is to find, or to get electrons, so that it would fill this entire shell with electrons. And we say this shell can house 8 electrons. So now we have 1, then we require, or the lithium require 7. But the tendency is either left or right. For the right is to fill the electron. The first objective is to fill the shell. If that is not possible, then it will lose the electron on that shell, so that it will just assume, or it will just make that shell disappear. Then it will assume the innermost shell's electronic configuration. I mean, it will just give up this shell, because it is not full, and it always wants the outermost shell to be full. So when it gives when the lithium give give up the outermost shell, this outermost shell, then it will only be this shell. Let me remove this outermost shell and the electron. Then it will only have this in the shell that is inner, before it will become the outermost shell, and it is full. So this lithium will be happy to stay with this shell because it is full, and lithium will become suitable to this lithium would always try to be stable by losing this other electron that is on the outermost shell, so that the shell will disappear, and this electronic configuration will become the stable form of this element. But to achieve that is not easy. It must find an atom somewhere to receive that electron, that single electron that is outside the that is in the outermost shell. And one important thing that I want you to understand is that when dealing with atoms, let's say this is nucleus, and this is outermost shell, and we have electron. Let's say this is for hydrogen. Remember, we must have something positive here because we have charges. This electron, as we said in our previous class, it has charge. It is negative charge. While proton inside the nucleus, when we say inside the nucleus, we didn't mean we do not mean inside something. No, what makes the nucleus is the actual proton and neutron. There is no any housing or casing. It's only the neutron and proton. In case of sodium, it's proton. So we have proton that it's proton that makes the nucleus of hydrogen. So we have hydrogen as having one electron and one proton, which the charges are equal but are opposite. We have this negative charge, let's say negative charge 1, and we have positive charge inside the nucleus, positive charge 1. So in total, we have 0 charge because we have positive and negative will cancel each other out. So in any situation where we have this electron is ripped off from the shell, then we have only dot of proton, because when you rip off the electron, this shell will go. Will remain. What will remain for this hydrogen is only the proton. So if you have no electron, you have only one positive particle. So you have +1 as the net charge. When I say net charge, when you do your calculation, positive and negative combined together, then the result will be net. So net charge will be +1. That is the reason we call hydrogen ion as proton. But I just said ion, hydrogen ion. How do we get to hydrogen ion? I will explain later. So now in case of lithium, since we have this, initially we said that we have this configuration of lithium, and this lithium, for any reason, if it loses the outermost electron, so that it will assume the electronic configuration of helium, because it's only helium that has this electronic configuration. But for this lithium to assume the electronic configuration of helium, it must lose the electron. But one important thing before we remove the electron is that this helium, since it has 3 electrons, then inside the nucleus here, it must contain the 3 positive particles, which are proton. So we have 3 positive charge inside, which balances we have 3 positive charge which balance these 3 electrons that are outside. So we have -3 as electron and we have +3 as proton. Net is 0. You don't have any charge. But in the situation whereby this lithium react with other element that makes this lithium to lose its electron, 1 electron, then in terms of our calculation to find the net charge here, this is supposed to be 3 initially, but now it's only 2. Why is 2? Because you rip off the first or the electron that is outermost. Then you have, instead of 3 now, you will have 2. So you have 2 minus or 2 negative electrons, and we have 3 positive electrons. The net the net charge will be +1, because when you say -2 + 1 is equal to +1. So as you can see, this is important of the mathematics we are teaching you from the beginning, which are from basis of calculation. So -2 + 3 is equal to 1. So here we have 3 protons. All these 3 protons charge will be cancelled by the electron that are out the shells. you have 3, but you have 3 positive here, but you have only 2 negatives. So these 2 negative will cancel only 2, and 1 will have nothing to cancel it, or that one will have nothing to cancel the charge. So you have +1 charge. That's why instead of us to write lithium like this, we will add plus here to tell you that yes, we have net charge of +1 instead of just lithium. When are we supposed to write lithium without positive charge? Is when this electron is here. When this electron is here, then we have 3 electrons, and we have 3 positive charge inside. Then everything will cancel. This negative will cancel positive. Then here will be no positive charge. We have only 0, and we don't write 0, so we just leave it as lithium. This will tell you that yes, this lithium is neutral because the net charge is 0. 3 protons with positive charge cancel. The charge is cancelled by the 3 negative charge in the shells. So that we have negative, we have neutral. But by the time you remove 1 electron here, and you did not remove 1 proton from here, you just remove electron, but you did not remove proton, then you have net charge of 1. Then you have +1 as the charge. But if it is +1, we just leave the plus because we know it's only +1. So this is basis of ion formation. When we form ion, then we have this form. This is lithium ion. It is not just lithium, but it's lithium ion. So when I tell you this is hydrogen ion, I mean something like this. When this is hydrogen and this is the nucleus, and you have electron on the outermost shell, then you remove the electron. Before you remove the electron, this is the where you write the hydrogen ion without putting anything here. That will tell you that this is neutral. You have single proton here and single electron here, which they cancel one another. At the end, after they cancel each other, then you have 0 charge. But when immediately if you remove this electron, then this positive charge inside the nucleus will make the atom to be ion instead of just atom. So we will have hydrogen plus here, or hydrogen plus. It's +1, but now we just leave it as plus. This is ion formation. So anything that will rip off electron or will add electron will form ion. Let me tell you how this is positive ion. Let me show you how negative ion comes about. If we have, let's go with lithium, because I think it's, yes, let's say this is the nucleus and this is the first shell. This first shell, we know it contains 2 electrons. Then let's go to the next shell, which is the outermost, which have single electron. This is lithium alone. This is what? Only lithium. This is lithium. If for me to make it ion to be positive, I will just remove 1 electron. This is lithium plus. But now I want to make it negative. For you to make it negative, it's just simple mathematics. You have 3 minus and 3 plus, you have your 0. And you want to make this place to be minus something. For you to make something minus, or for you to make this simple calculation to be minus, you just add 1 minus so that your answer will be minus. So instead of just putting 3, I'll just add 4. Then minus 4 plus 3, you will end up getting minus 1. But let me just put, but how do we achieve this minus 4? It's just by getting another electron. Just find electron anywhere and put it in on this shell. If you put electron on this shell, now you have what? 4 electrons. You have what? 4 electrons. These 4 electrons, where are they coming from? Or you add electrons alone without touching anything inside the nucleus. You do not add any proton, you do not remove any proton. So you have constant number of proton, but what? Additional, you have additional electron. This is how you get your what? Your 4 here. So you have 4. You end up having minus 1. So now we know how to get minus 1 and plus 1. So if you have minus 1 here, you just write minus 1 here. But since it is just 1, you can erase this one and put lithium minus. So if I write something like this, Li minus, I mean I have additional electron from the neutral form of this element, and adding electron to this form or removing electron to this to the neutral form will cause the atom to become an ion. So when I say lithium atom, I mean neutral lithium. When I say neutral ion, I mean altered number of electrons on lithium, or lithium that has altered number of electrons. That alteration can be addition or subtraction. When you have addition of electron, that means you are adding more negatives to the shells. Then the total charge will be negative. When it comes to removal of existing electrons from the normal lithium, then you end up having what? Positive form of the ion. That's the basis of formation of ion. This is common in atom like hydrogen. You can have hydrogen, then hydrogen can hydrogen plus electron. If you have electron, we write electron as E negative, then it will become what? Hydrogen ion. So let's do for oxygen. Okay, let's see sodium. This is sodium. The electronic configuration of sodium is something like this. This is nucleus. You have first shell, you have second shell, and you have another shell. This first shell contains 2 electrons. The second contains what? You have 8 electrons. 8 plus 2. This electron contains 8. Then you have 2 in the middle that makes it 10. Then you have plus 1 here, which is 11. So this electronic configuration of neutral sodium, and this neutral sodium, it always loses this electron, and losing this electron will end up, when you lose electron, it's like we are losing negative charge. You have 11 minus, you have plus 11. Your total is 0. But now you lose 1 electron, then you have, instead of 11, you have 10. Then you have what? Here will be plus 1. That's why sodium has plus 1. So sodium is positive ion, always positive ion. Sodium makes positive ion. Why? Because it always want to assume the full outermost shell. For it to assume that, it must lose this electron. Losing this electron makes it positive charge. That positive charge has its own consequences. When something is positively charged, or when element is positively charged, then it will react with other. It will react with a lot of other atoms. So now let's talk about concept of electricity or positivity or ion. being ion. When we have nucleus here and you have shell and you have electron here, this electron, remember, is not as we draw, it is like we are drawing it like this. It is moving around this part. This is actually not there. This line is not there. It's just like open space. You have nucleus. What forms the nucleus? What forms the nucleus is the proton and neutron, and this electron is just at the outer, just at the outside. There is no anything physical, nothing like this line or specific something that you can touch, nothing like that. It's just telling you that this electron is just moving around this nucleus. Moving around this nucleus means that it is just this where it is. It comes this, it comes here, it comes here, moving constantly. This moving, so if you trace the path, it would be like this way. That's why we always draw it like that. But there's no anything like shell, physical shell, that it is like something cycle, nothing like that. It's just open space, just space where this thing is moving. We are just making it as something solid for just indication. So what makes this electron to be moving around the nucleus without this electron falling down? This is because there is attraction between positive charge and negative charge. When we are having, this is positive charge and this is negative charge, they tend to pull each other. This one will come, this one will try to come. They're trying to meet. They're trying to meet and cancel one another. Then that means this proton is pulling this electron towards it, so that even if this electron change position, even if it changes position to this position, this electron will still pull it toward itself. That's what maintain this electron in this path. And why this electron did not fall, did not just come into the nucleus? That is because the velocity that this thing is moving is tending to take it away from the nucleus. So now we have two forces. We have another one is for the velocity of the electron, that is taking the electron away, and the next force is the force that is pulling the electron toward the nucleus. So this balance between these two forces, the resultant will be this way. This way. That's why this electron is moving around. You will understand this when we are talking about plotting solar system planets. So this is that's what holds the electron. And remember why this force exists. This one, why this force exists is that this electron and the proton are oppositely charged. This charge that are opposite, this one is negative, this one is positive. The attraction is what constitutes this force, while this one is velocity. So imagine in a situation whereby you increase this force, then this electron would come very close to the nucleus. And anything we have positive and negative charge, then attraction will happen. So now let's go back to our sodium. Imagine you have positive sodium, positive ion here, and you have another ion, or you have, yes, let's make another ion which is from chlorine. You have first shell, you have second shell, you have first shell, you have second shell. Let's do it for chlorine. You have electron, this first 2, 3, 4, 5, 6, 7, 8, 9 and 10. So you have what? You have 10 electrons here. This electronic configuration of neon. Then you have 1, 2, 3, 4, 5, 6, 7. This is for chlorine. When you do the electronic configuration for chlorine, is what? Is 17. So you have 17. You have 10 inside and you have 7 on the outermost shell. Now this electron, this electron is not paired. What I mean by paired is it does not have its brother. If you see let's say brother, if you see this, we have 2 electrons close together while this one is single. So this having single electron, this chlorine will always or is praying for an electron to come and fill this space so that it will complete its own outermost shell, because this outermost shell also contains or houses 8 electrons, and now it has only 7 electrons. So it's always praying to have 1 electron. And as we said for the sodium, this sodium we have 11 electrons, where it always trying to throw this electron away. So if these electrons are in the same, or if these atoms are in the same container and appropriate heat is applied, then this electron will move from sodium and come and put itself into this electron. That would automatically change these 2 electrons. One is chlorine. This chlorine is having 17 proton. We have negative 17. We have negative 17 and we have positive 17, which make it 0. Now it gain 1 electron here, which will make the number of electron to be 18. This making it 18 here, making it 18 will cause our calculation to end off with negative. We have -1. And this sodium, as we did in this calculation, that when you remove 1 electron, the total or the net charge will be +1. And now ultimately you have 2 ions in that place. You have this chlorine will become Cl. Cl is for chlorine, so you have Cl, because you have -1. Now we have Cl minus, and for sodium we have sodium plus, as we did here. So now whenever you have sodium plus this chlorine minus, you end up having what is called sodium chloride. You'll have what? Sodium chloride. So this is reaction. For reaction to happen, the electrons, or the electron between the reacting species, we call this reacting species or reactant. When we say reactant, we mean those that will react, and this is product. When we what is the meaning of product? Is just product. Product is final, is what is obtained at the end of the reaction or at the end of reaction. So these are reactant. This is reactant. These 2 is reactant. So both of them, we have 2 reactant. That's why I'm adding S. So you can say reactant or reacting species. You can say reacting species. Reacting species. This is reacting species. That means those particles or elements or compound that form the reactant. So they are reacting species. So you have sodium and chlorine, you end up having sodium chloride. How the reaction happen is just by taking electron from sodium, which make the sodium positive, and put it on electron, which make the electron negative. And now positive and negative things in one place will automatically become react and become product. By this, ladies and gentlemen, we have made it to this point of reaction. This type of reaction is called ionic reaction. Ionic bond. This type of reaction is called ionic. Why is it ionic? Because the reactant species has become ions that make them to react. They become ions that make them to react. This is called ionic bond. Ionic bond. Don't forget, it's called what? Ionic bond, because the reactant species become ions that make them to react. So this is ionic bond. What's its name? Ionic. Ionic. Ion. What is ion? Or we say any atom that loses or gain electron that make it to have charge, that is ion. So ionic. This is ionic. When I say ion, I mean this is sodium. This is sodium, normal sodium. This is sodium ion. This is chlorine. This is chlorine ion. And I hope and I pray you can derive or you can prove how are we going to reach from neutral sodium to ionic sodium or sodium ion. I hope you can explain how. So this is ionic. What is ionic? Ion is just the name, but ionic, something that involves ion, something that involves charge. So ionic bond is what? Is the union between sodium and chlorine. Is types of union where we have positive and negative ions together to give a neutral product. This plus will be cancelled by this minus. That's why at the end we have sodium chloride, where we don't have any charge here. Why? Because this plus of sodium is cancelled by the negative of the chlorine. That's all you want to know for ionic reaction. Ionic reaction, there are many ionic reactions in chemistry, which we are going to see them one by one. Hope you enjoy this lesson and you understand this lesson. If you understand this lesson, what I want you to do is just to start with hydrogen and helium, and try to make all this hydrogen helium up to the 20th element, which is calcium. Try to make them ions. Try to make them ions. If you want to make ion, please, if you have, since we have 8 electrons in outermost shells of some of the atoms, if you have shell that contains 8 electrons, then consider taking the electrons away when they are not up to 4. When they are 4, then consider adding. You can lose 4, it's fine, but consider adding electrons. But when they are 3, you can take them away. But when they are like 5, then try to add electrons so that you fill up the shell. Like for example, let me give example with aluminium. Aluminium, is having, let me just draw the outermost shell. Let's say this is shell. Let me just draw the outermost shell. The outermost shell of aluminium has three electrons in the outermost shell. So this outermost shell of this aluminium, we know atom always tends to have complete outermost shell that has all the electron in its outermost in the atom tends to have complete outermost shell. I mean shell that has complete electron in the outermost shell. Then this aluminium, because it's not up to half, so instead of it tending to lose gain electrons so that it will fill this space so that it will become 8, no, it will lose these electrons so that it end up losing all 3 electrons. So now you have aluminium not +1 now. Why? Because it loses or it loses 3 electrons. Then you have since it loses 3 electrons, before we have, I think aluminum is 13, so you have -13 and you have plus 13. Now you have 0. When it loses all these electrons, it loses what? These 3. It has only 10. Then you have 13 or 10 minus 13 or my plus 13 minus 10, you have +3. You have +3. So this aluminum will lose all these 3 electrons. As it loses 3 electrons, you must write +3. That's why aluminum is always +3. Or they write 3+. So it has 3+. This 3+ is for aluminum. Some will have 2+. You figure it out. Do the exercise, which is start from hydrogen up to calcium. All of them make this electron lose or gain electron depending on the need. If you need only 3 to fill the shell, please make it or fill the shell. But when it needs 3, or when it has when a shell has only 3 on the outermost shell, then you can remove the whole 3. But once it reaches 4, please consider adding instead of removing. Thank you very much. Hope you enjoyed this lesson. As always, do the assignment, like the video, comment in the comment section, and share our videos to others so that a lot of students will benefit from the lesson. Thank you very much, my new science school. We always wish you good luck, and if you want to join our WhatsApp, you can always do so by using a phone number, which is 081 28 14 18 16. Chat us on WhatsApp. Thank you. See you in next lesson.